Hello and welcome to another video. In this video we're going to be working on letter Y in a grid. And in the problem you're given an n by n grid where n is odd and every single number is a 0, 1, or 2. And because it's an odd grid, you can make a Y shape on the grid that looks like this. So you start at the middle cell, you go straight down, and you also go diagonally left and diagonally up to make a Y. So all of these cells on the grid, on this diagonal and here, are in the Y. Similarly, in this example here, the Y looks like this. So all of these cells are in the Y and everything else is not. And your task is to transform every cell in the Y to one number and every cell outside of the Y to another number, such that every cell in the Y is the same and every cell outside of the Y is the same, and they can't be the same number. So if you look at this first example, you transform every cell in the Y into a 1 and every cell outside the Y to a 0. Whoops. And you would just basically want to write down how many operations that took, considering you can change any cell to any number. So in this first example, to make everything on the Y a 1, you just have to transform this into a 1, and then you make everything else into a 0, which is 1 and 2 operations. So it's 3 total. In the second example, you transform every cell on the Y to a 0 and everything else to a 2, and it takes 12. And so this is a pretty easy problem, and the constraints are also pretty small. So the it's an n by n grid that's only 50 by 50. So I think this is like a very easy problem, but basically all you have to do is you just have to be able to know what cell is on the Y and what cell is not. So we just like go through this grid, figure out what cell is on the Y and what cell is not. So in order for a cell to be on the Y, let's make conditions for the cell to be on this left diagonal. So we're going to do left diagonal, right diagonal, and then this bottom thing here. We're going to split it up into those 3. So for the left diagonal, in order for this to be true, row has to equal column, and row has to be less than n over 2. Because for a left diagonal, if you think about it, like this is cell 0, 0, 1, 1, 2, 2, and so on. So every cell on the left diagonal will have the row be equal to the column, but you only want to have left diagonal up until the middle, right? So if this is like 5, n over 2 is 2, and you just lower divide. And so basically row has to be less than 2, and row has to be equal to column. And that would give you every single left diagonal. For the right diagonal, it's row plus column has to equal n minus 1, and the same row has to be less than n over 2. So let's copy this over here. So like the height makes sense, right? Because once again, you only want to check rows that are above this row, above the center row, whatever your grid is. You always want to go above the center row. And the reason this is the case is because like here n is 5 and this is 0 indexed. So this row here, let's just move it in the middle more. This row here is 0, 4. Then this one over here is 1, 3. And then it's going to go like 2, 2, 2, and so on and so on and so on. So basically, every cell along this diagonal adds up to 4. Like if you add up the row and the column, and these are the only ones that do this. So these are like some small diagonal tricks you can do by doing a few problems, but essentially that's how you do the left and the right diagonal. And then after you do that, it's pretty easy, right? You just check like, is my cell on the left or right diagonal, or is it on this bottom thing? So this bottom thing is also pretty easy. It's just let's write this down. So the row has to be greater or equal to n over 2 now, right? And the column has to be the center column. So column has to equal the center column. And floor divide once again. So here, the center column, this has to be column 2, right? Because n is 5 in this case. So the column has to be column 2 and row has to be 2 or lower. So 2, 3, 4. So basically, once you do that, like once you know what cell is on the Y and what cell is not, you just have 2 things. And for every cell on the Y, all you have to do is write down how many 0s, 1s, and 2s you have on the entire Y. So for the Y, we're going to have an array of 3 numbers: how many 0s we have, how many 1s we have, and how many 2s we have, right? And you just do that in like an if statement as you're traversing. Is it on the Y? If it is, what number is it? And then just update that accordingly. Same thing we have to do for everything outside of the Y. So we have to do this on the Y and not on the Y. And so not. And then it's pretty easy, right? Like we only have a few choices. Like we can either make all the cells in Y 0, 1, or 2. If we make all the cells in Y 0, then outside of the Y we can only make it 1 or 2. Same thing here. If Y is 1, we can only make it 0 or 2. If Y is 2, we can only make it 0 or 1. And you can just kind of try all these combinations. So let's just go through one iteration of that. So let's take this original Y. So this Y has 2 zeros. So 2. And then it has 2 1s. So 2 and then 3 2s. So you'd basically say like, okay, if I want to make everything 0, then I have to change all of these numbers. So I'd have to change 5 numbers. And if I want to make everything 1, then I'd have to change these numbers. I have to change 5 numbers. And if I have to make everything 2, then I would change these. And so you do this for the Y, and you do the same thing for the not Y, and you just do all combinations, right? So for all of these, you just literally, like, it's a basic calculation once you know how many cells are of each. So here's the code. Like I said, pretty easy. For the Y, you keep track of 3 numbers, number of zeros, number of ones, 1 and 2s. And for the non-Y, same thing. Go through the entire grid, and you just check. So this is if it's on a diagonal. This is if it's on that bottom of the Y. If either one of those is the case, then you update that number in the Y. Otherwise, you update the value in the other. And then you just minimize the result. So you just take the sum of all these, and to change something to something else, pretty easy calculation. So you just loop for I in range 3, right? So you try all of these and all of these, and the only thing you can't do is they can't be the same. So you can't make like all the Y's 2s and all the rest 2s. So if they're the same, you just go to the next one. But otherwise, it's literally just to convert everything in the Y to something. It's going to be the total of the Y minus whatever you're converting to, because those are already converted. Same thing for the other one. So you just add that up, and then you basically have like 6 different cases. So this is like super fast. You can just try all combinations. You can try like some optimized thing, but because there's only 6 combinations, it doesn't really matter. And then yeah, you just return. So we can try this. So I think it's a very easy problem as long as you know how to calculate what's on the Y and what's not. Like there, it's just literally brute force because there's only 6 combinations. Maybe if like you can convert everything to like 10 to the 9th numbers or something, you'd have to have some optimized stuff. But other than that, pretty easy. Yeah, and then time and space here. So this is just O of n squared, right? We're going through our whole grid. And space is O1 because we're only using an array of length 3 for both of these. So I think this is like a very easy problem for a third problem of the contest. But yeah, if you have any questions, as always, just write in the comments. And if you did like this video and this is helpful, please like and subscribe. And I'll see you next one. Thanks for watching.